So today we're going to be doing lesson 4.7, which is notes on rational exponents, not rational expressions. So there are a few important key rules to know about a rational exponent. A rational exponent is a fractional exponent that can be expressed as an nth root, meaning, so basically the main idea here is that any radical can also be expressed as a root, okay, as a root. And we have a rule and way that we do this. So the rule is basically you have your radicand, what's underneath the radical, and you have that to some power. Now even if there is no power that is on whatever your radicand is, it's a 1. It's an implied 1. Now if there is a power, that's the power you use. And then the index is the type of root you're taking. So if it's a square root, it's 2. Usually square roots don't have a 2 there, they just are an implied 2. If it's 3, it's 3. Whatever that number may be, basically that's the denominator of your exponent. So an expression with rational exponents is simplified when the following 4 conditions are met. No negative exponents, not a complex fraction, only positive integer exponents in the denominator, and remaining radical index is the least number possible. So basically you simplified the radical as much as possible, simplified the fraction. So like 2/4 you simplify to 1/2. When simplifying rational exponents, here's the rules that we look at. So when you multiply common bases, you add exponents. When you divide common bases, you subtract exponents. And when you put to another power, you put an exponent that already has an exponent to a power, you multiply. So let's go ahead and look at these examples. It says express each exponent exponential expression as a radical and each radical as an exponential expression. So let's go ahead and zoom in. So on the first question, all you have to do is, if it's already given to you as an exponent, you're going to rewrite it as a radical, and the denominator is going to be your index, and the numerator is going to be your exponent. So it's going to look like this. Sorry, my tablet kept shutting off on me. It's going to be x to the 3rd power, and it's going to be the 7th root. So you basically put the 7, whatever your denominator is, goes on the outside of the root, okay? And whatever your exponent is the number on the top. So that's how you go from fractional exponent to radical. So do I have any questions about that? All right, let's go ahead and look at number 2. So on number 2, what do you notice about the exponent?
It's negative.
It's negative. So does anybody remember how to get rid of a negative exponent? You put it in the denominator. So now it's a positive exponent. So then from here we can now convert it to a radical. So we do our radical symbol. It's going to be y to the 4th power. It's going to be the 5th root of y to the 4th power. So the denominator is your index, which goes on the outside. The numerator is your new exponent. And this will be your final answer on this question. Can't do anything with that. So if there is no index, that means that it's an implied 2. So if it's anything but 2, you need to put 1 there. If there is no exponent, it's an implied 1. So if there is anything except for a 1, you have to put it in there. So the next one here kind of goes into what I was talking about. So what is the implied exponent on the a? 1. So this is actually going to be a to the 1/5 power. Alright, and then we'll go ahead and do number 4. So what's b going to be to the? Good, 3/5 power. Next one we'll look at is example 5. So this one is to the 3rd power on the outside. Doesn't really change it much, because really all that means is that we have the 4th root of c times the 4th root of c times the 4th root of c. And if you remember back to the last lesson that we did, if you have 3 or any number of things that are being multiplied together that have the same type of root, you can basically just put them all under one root. And what is c times c times c? C to the third. Now that we have this, we can convert it into a fractional exponent. And what's that going to be a fractional exponent as? Good, 3 over 4. C to the 3 over 4 power. See, your goal with this lesson is to be comfortable flipping back and forth from each type of expression. And then the next one we're going to look at is negative, so we have to put it under 1, like this. And then this is going to be the third root of 64. Now, as you can see, I don't have to put the 1 as the exponent because it's redundant. We already know if there's no exponent, it's 1. But 64 is actually a perfect third root or cube root. Anybody know what it is? 4. So if you break this up into 8 and 8, and you break up those 8s, you'd end up with two groupings of 2. Three groupings of 2, basically. So your answer here ends up actually becoming 1/4 because of the perfect cube root in the denominator. So before we move into operations with these, does anybody have any questions about the notation? It's pretty straightforward to understand once you guys see it, I think. So now we're going to do some operations. So this is just a refresher on some operations we do with exponents. If you have a common base and you're multiplying, you just add the exponents. If you have a common base and you're dividing, you subtract the exponents. If you have a base with an exponent put to another exponent, you multiply those exponents. If you have two different bases, numbers, so like 2x or whatever it is, times each other to the same exponent, you can separate them, each putting it to that exponent. And the same goes for division. And the last rule is the one we've been talking about. If you have a negative exponent, you can make it a fraction under 1 to make it into a positive exponent. So now that we've been through those rules, let's go ahead and talk about some operations that require these rules. So when you're multiplying two roots together, but they're not the same root, you can't put them under one root, so you have to convert them to fractions, fractional exponent roots. So anytime it's just the square root, it's always 1/2. And that's because the implied exponent on anything that doesn't have one is 1, and the implied root for anyone that doesn't have one is a regular square root 2. So that's the reason it's 1/2. So square root is the same as 1/2. Do you have a question? Yeah, sure. Sorry, I didn't see if you were raising your hand or not. And then what is the exponent going to be on this one? Good, 1/4. So we end up with 3 to the 1/2 times 3 to the 1/4. So what do we do with exponents when they're multiplying?
Add them.
Good, we add them. Anybody know what 1/4 plus 1/2 is?
2, 6, 1/2.
Yeah, so technically speaking, you'd have to convert this. So I know that 1/2 is 2/4. So 2/4 plus 1/4 is 3/4. Some of them you can do in your head, but yeah, you just convert it. So that'd be your answer. And if your answer was asked to be written back into radical form, you just have to know how to convert it back. So it'd be 3 to the 3rd and then 4 on the outside. So I'm just going to be doing each one written both ways because depending on the question, they may ask for either representation. So now the next one we're looking at is example 8. It's negative, so we have to bring it to the denominator to make it positive. Now 2.5 is actually the same thing as 2.5, right? And that's a mixed number. Do you guys remember how to go from mixed number to improper fraction? You multiply 2 times 2 and then add that to 1. So that becomes 5 over 2. So 2.5 is the same thing as 5 divided by 2. So that's 6 to the 5th halves, like that. And then we can rewrite that as a radical if we wanted to. like this. Now, in this case, this will actually simplify, okay? Now, I wouldn't recommend putting 16 to the 5th power. I'm just erasing it to move it up higher so I have room. I wouldn't recommend putting 16 to the 5th power in your calculator. It's going to be really big, and then trying to factor that. So let's talk about a little bit of a trick we have here. So technically speaking, this just means we have 16 how many times? 5 times. So 16 times 16 times 16, and so on. Now we're taking the square root of this. So we're looking for groupings of what? 2. So if you find groupings of 2 that are not actually fully factored or prime, that's okay too. We know that these each break up into 4 because we know that 16 is a perfect what? Square. So basically, you're just going to take the square root of each of those 16. So what's the square root of 116? 4. And then the square root of this one's also 4. Times 4 times 4 times 4. So basically, you're just taking the square root of each 16, which is 4. So your answer comes out to be 4 to the 5th power, which is actually 1024, and don't forget it was under 1. So that's an easier way to calculate this square root without actually, literally if you multiply this out, you're going to get a huge number to factor. It will take you the whole page. So this is actually a little bit of a trick. If you haven't, like one that's already a perfect square to a power, you just do it how many times that power is, basically. So does that make sense to you guys why we had 5 4s there? We take the square root of each 16 separately and then put it to the 5th power. So now the next one we're going to look at here is negative 32. So if I transform this into a radical, this is going to become the 5th root of negative 32 to the 4th power. Now, what do we know about negative numbers to an even power? What do they become? Positive. So anytime you have a negative root to an even power, you can basically just make it positive. Okay, you don't need to deal with it being negative. And that's because it's to an even root. So 32. I'm not going to multiply it out 4 times. That'll become really big. So I'm going to try to take the 5th root of 32 individually and see if I can take anything, and then I would just multiply it or put it to the 4th power. So another way you could actually represent this, if you prefer, is to do the 5th root of 32 and then put the whole thing to the 4th power. So that's the same thing as this. So if you feel like that makes more sense to you, why that is, you can put it like that. So let's go ahead and break down 32. So what can I break 32 up into?
16 and 2.
Good. And then 16 breaks up into?
4 and 4.
Good. Which breaks up into?
2 and 2.
2 and 2. So in total, how many 2's do I have? 5. Isn't that what we want? Because it's a 5th root, right? We want a grouping of 5. So the 5th root of 32 is actually 2. But how many times are we taking that 5th root?
4.
Yeah, 4 different 32's. So basically you're going to take 2 to the 4th power, 2 times 2 times 2, which is your answer, which is 16. So you put it back to the power of whatever your exponent is here. And that's kind of a faster way to do larger quantities, okay? So let's go ahead and look at example 10. So with the way you've been learning it in the past, we know that if these are the same type of root, we can make one big root, but they're not, so we're going to have to convert them into exponents. So this is going to be x to the what power? Good, 3/4. And then over x to the? Good. And x to the 2/8 reduces to what? 1/4. I just reduced that fraction. Now when we divide, that means we do what with our exponents? Subtract them. Good. So that actually comes out to be 3/4 minus 1/4, which is? Good. 2/4, which is 1/2. And do you remember what anything to the 1/2 power is as a root? Just a regular square root. Yep. So depending on how the question is phrased, either one of these is a correct answer. If they want the radical, if they want the exponent. Those are both correct and congruent. So the next one we're looking at, if there is no index, what's your index? 2. 1 is the exponent. So this is going to be x to the what power? Good, 3/2. And this is going to be x to the, good, 2/3. Division, we subtract. Numerator, exponent minus denominator, exponent. These are going to need to find a common denominator. So I see that my common denominator is going to be 6. So I can multiply the first set by 3 on the top and bottom, which will give me 9/6, which is the same as 3/2, times, I'm going to multiply the second set of fraction by 2 on the top and bottom, which is going to be 4/6. So basically I just found two equivalent fractions that have the same exponent, so now I can just subtract them. So what is 9/6 minus 4/6? 5/6. And as a radical, that's just a 6 out here, and it's x to the 5th, like that. Alright, so this one you're going to have to convert to a radical in order to simplify it. So the 3 goes on the outside as your index, and this whole thing is to the second power on the inside here. So our goal is going to be to first put it to the second power. So what is -8 to the second power? Good, 64. X squared, because we put x to the second power. And then what happens to the square root on the inside that is put to the second power? Good, it goes away. And then obviously right here I can just combine the x's, which becomes 64 x to the third y. Now 64 is a perfect cube root. I think we did this one earlier in the lesson. Anybody know what it is? What times what times what? 4. 4 times 4 times 4 is 64, meaning it's a perfect cube root. And then what is the cube root of x cubed? X. What can I do with the y? Nothing. Good. Exactly. Yep, it doesn't have any exponent on it, so I can't group it. So my final answer is 4x times the third root of y. So that's all I have today. It's a really short lesson.